Good morning. Welcome to the second day of transforming quadratic function. Last week we talked a little bit about how do you tell if you have a quadratic function, if that quadratic function is going to be wider or more narrow than our parent function. Remember we talked about that our parent function was x squared, which is this one right here. Always the one that goes through the center, 0, 0. So today we're going to talk about how do you tell if our quadratic function is going to either be moving up or be moving down. Alright, so let's look at the example on the left. We have two graphs, one red one and one blue one. The red one, this one here, is our parent function, f of x is equal to x squared, and the blue one is our second function, g of x is equal to x squared plus 4. If you look at these two graphs closely, it looks like they are identical. The only thing that's different between them is the blue one is moved up 4 units up. And the way we tell that from our function is if you look at the c value. Again, the c value is the one all the way at the end without a variable. So you look at the c value here, the plus 4. This plus 4 tells us that if we're starting at our original parent function, we're going to be moving up 4 units from our parent function. So this plus 4, the plus means going up, 4 just means we're moving 4 units up. So down to the definition, if we were to translate just another word means shift. If we were to shift up, we know that our function will be shifting up from a parent function if our c value is greater than 0. If it's greater than 0, we know that the graph of the parent function, f of x squared, is translated c units up. It's going to be shifted c units up. So let's look at the graph to the right. Same concept. The red function here is our parent function, which is f of x equals to x squared. And our blue function here will be our second function, which is h of x is equal to x squared minus 2. So if you look at the c value, our c value for h of x is minus 2. Since it's minus 2, we know that minus means we're going to be going down. We'll be going down 2 units. So for the definition, if we're going to look at a graph and tell if it's going to translate down or shift down, we know it's going to shift down if the c value is less than 0. Any negative values will tell you that the graph of the parent function, which is f of x equals to x squared, will be translating c units down. So in this case, our c unit was negative 2, and we're moving 2 units down. Alright, with that in mind, I want to use that idea and everything else we learned about graph this far, and we're going to see if we can describe a function and the width of the function, the direction of the function, and where the vertex is, just by looking at the given function and comparing it to the original parent function. So let's look at the bottom left example. I want you to compare the graph of c of x is equal to 3x squared minus 5 with the graph of f of x is equal to x squared. So let's start by comparing the width. Is c of x wider or narrower than f of x squared? And we remember from last week, we know that if our a value is greater than 0, it will be narrow. So we know that since the a value here, is bigger than 0, that means this c of x function will be more narrow than the x squared function. Narrower than the graph of f of x squared. What about the direction? Is the c of x function, is that going to open up or open down? A few weeks ago we learned that if a is greater than 0, if a is greater than 0, it go up. Alright, so that means since 3 is greater than 0, it's going to open upwards. And we also know that the graph of f of x squared also open upwards, because of its coefficient. A is a 1, so it's greater than 0, so it opens upwards. Alright, so the axis of symmetry, we want to see if we can compare those two, see if they're the same or see if they're different. If they are different, where do they lie? If we just look back up here, scroll this down, the axis of symmetry for x squared for a parent function is always going to be at x equals to 0 all the time. It's always going to be at x equals to 0. It's never going to change. So we're not going to try to find the axis of symmetry for x squared, but just so you know, it's always at x equals to 0. So the axis of symmetry for the c of x function, I'm going to write it down here, c of x is equal to 3x squared. I'm going to put a blank here, plus a blank, minus 5. Put a blank because we don't have a 0. We don't have an x here, so I'm just going to put a 0x. Remember, this is our a, this is our b, and this is our c. So if we were to find our axis of symmetry, I made a mistake here. Our axis of symmetry is supposed to be x equals, not y equals. X equals negative b, and our b is 0, so it'll be negative 0 over 2 times a, and our a value is 3. So 0 over 6, which is equal to 0. So our axis of symmetry is that x equals to 0, which is the same as our parent function, x is equal to x squared. Alright, so let's try to find the vertex of these two here. Alright, so we know that the vertex for f of x is equal to x squared. It's at 0, 0. That's where the vertex is. So let's try to find the vertex for c of x. C of x is equal to, and to do this, remember, when we find the vertex for a function, you're going to use your axis of symmetry, your x value for your axis of symmetry, and plug into every single x value that you have in your function. So c of x is equal to 3 times 0, because that was our value for x for the axis of symmetry, minus 5. So c of x, or c of 0, is equal to 3, 0 squared is 0, 3 times 0 is 0, 0 minus 5, so c of 0 is equal to negative 5. So the vertex for c of 0 is at 0, negative 5. And to double check and see if we answer these correctly, you can also go to Desmos and just see if our c of x is more narrow, or if it's not more narrow, if it's wider, see if we answer that correctly. And let's see if it opens upwards, and let's see if we have the vertex right. And so let's compare both of these vertex and see if our graph is correct. So I'm going to open up Desmos. So as you can see, our graph, the red graph is y is equal to x squared, and the blue graph is the 3x squared plus 5. So as you can see, our vertex for c of x is down at negative 5, 0, and the vertex for x squared is at 0, 0. And we are right, our c function is a lot more narrow than our parent function. And we found all of this out just by looking at the equation. Alright, so I encourage you to pause the video and try example 2 or the example on the right and see if you come back and check with my work and see if we have the same thing. Alright, hopefully we gave that a try. So let's compare the graph of g of x equals to negative 1/3 x squared plus 2 with the graph of f of x equals to x squared. So let's compare if g of x is more wide or more narrower than our parent function. Alright, we know that the graph of g of x equals to negative 1/3 x squared plus 2 be wider because our a value is less than 1. I made a mistake in the example on the left. I meant to say that the a value is greater than 1, not 0. If it's greater than 1, it will be narrow. The example to the right, if it's less than 1, for example, 1/3 here is a fraction, less than 1, it will be wider than our parent function. Next question. The direction of the graph, is g of x going to open up or open down? This one will open downwards. Because our a value is negative. Anytime it's negative, it's going to open down. And our parent function is going to be opening upwards. So the difference between them is one's going down and one's going up. Axis of symmetry. We know that our parent function, f of x, equals to x squared. The axis of symmetry will be x equals to 0. Our g of x function, that's equal to negative 1/3 x squared plus blank, which is our 0x plus 2. So we know that negative 1/3 is our a, 0 is our b, 2 is our c. So to find the, and again I made a mistake, this is not a y, this is an x. Again, our axis of symmetry for g of x would be x is equal to negative b, which is a negative 0, over a, 2 times a, 2 times a negative 1/3. And 0 over anything will always be 0, so our axis of symmetry will also be x equals to 0. So again, both of these have the same axis of symmetry. Alright, so let's look at the vertex. Let's slide this up just a bit. So to find the vertex, we know that our function f of x equals to x squared. The vertex is at 0, 0. Our g of x function, again, to find where the vertex at a function, you're going to use whatever you found for your axis of symmetry. In this case, we found x equals to 0. Everywhere you see x in your function, you are going to replace that with a 0. So g of 0 is going to equal to negative 1/3 times 0 squared plus 2. So g of 0 is equal to 0 squared 0. 0 times a third is also 0, so 0 plus 2. So g of 0 equals to 2. Therefore, our vertex for this would be 0 for the x value and 2, positive 2 for the y value. Again, we can look at decimals and see if our function, what we put down, is correct. Let's see if this graph is wider than our parent function. Let's see if it opens down, and let's see if we have the correct vertex for these two functions. So, alright, let's pull up decimals. So, as you can see, the red one, again, the red one is x squared. The blue one is our negative 1/3 x squared plus 2. So we are right. X squared again, vertex is at 0, 0. Our blue function vertex is at 0, 2. And the blue one is a lot more wider than the red one here. And the blue one is going down, and our parent function is going up. So again, this is one way to check if you to see if you made any mistake on your functions. So today we learned how to identify if the function we're giving is going up or down when we compare it to our parent function, and we're able to put everything that we know about graph, about how wide or how narrow they are comparing to the parent function, the direction they're moving, either up or down, and finding the vertex and comparing the parent function to our given function. Again, if you have any question, ask me during word time, and the assignment should be in Schoology. Remember that our final for quarter 3 is coming up in a few days here on Friday, so make sure you study and ask me any question if you have any. Thank you, and you have a great day.